Lesson 4-7 is called Least Common Multiple, or LCM for short. In order to do this, you need to know what a multiple is. So a multiple is basically the answer you get when you multiply two factors. So the multiples of 5 are 5, 10, 15, 20, 25. That's because you're counting by fives each time. So multiples never end. They keep going because you can keep multiplying by a number to get another multiple. So if you try this one on your own, what are the first 5 multiples of 8? So you have to think to yourself. 8 is our first multiple because 8 times 1 is 8. Then you have to think, well, what's 8 times 2? What's 8 times 3? What's 8 times 4? Keep doing that. Go ahead and write them down. And here's your answer. So our first 5 multiples of 8 are 8, 16, 24, 32, and 40. Now that you know what a multiple is, we're going to be focusing on finding common multiples of two numbers. So the one that we're really interested in knowing is the least common multiple. So if I choose the numbers 4 and 6, if I was to find the least common multiple, the first thing that I would do is I would start listing multiples. So I would list a few multiples of 4, and then I'd list a few multiples of 6 until I find one that they have in common. They might have more than one in common. So for example, they have 12 in common here, but they also have 24 in common. We want the least, or the smallest number, the least. So that would be 12 in this problem here. So I would say the LCM of 4 and 6 is 12. That would be my answer. Try one on your own. I'm going to give you some time, and then you can pause this and then press play when you're ready to check your answer. So those are the multiples that I need. You might have more, and that's just fine, but 60 turns out being the least common multiple of 10 and 12. Here is a story problem where you would use least common multiple. Buffalo Wild Wings is giving away free wings to every 20th customer and a free soda to every 15th customer. What customer would be the first to get both free wings and free soda? To do this problem, you want to think about the first customer to receive free wings, and that's the 20th customer. So that means the 20th customer gets wings. The next customer after that one to get wings would be the 40th customer, because every 20 customers get wings. So after the 40th customer, the next person to get wings, the 60th customer. So I'm going to label this W for wings. All right, well, every 15th customer gets a free soda. So I'm going to say S for soda. So that means the first person to get a free soda is the 15th customer. And the next person after that one to get a free soda is the 30th customer. So you're seeing how multiples are showing up in this problem. So far I've listed off multiples and I don't have a common multiple. So I would have to keep going. I want you to press pause, and I want you to continue the list to see if you can find the least common multiple. So press pause. So hopefully you have a list something like this, and you'll notice that 60 shows up on both lists. That means 60 is our answer, but don't forget this is a story problem. So think to yourself, how would you label this? 60 what? If you said customer, you would be correct. The 60th customer would be the answer. Another story problem. Talking about trains. A train, for each of the train lines shown in the table on the left, or above in this case, has just arrived. In how many minutes, that's going to be our label, in how many minutes will a train for each line arrive at the same time again? I'm going to I want you to pause, reread the question, see if you can figure out the answer. So the first thing you would do in this problem is, I like things color-coded, so I did yellow, green, and purple, and I know that the yellow train arrives every 8 minutes. So the first time the yellow train would be there would be 8. The first time the green train would be there is 10, every 10 minutes. So it looks like the yellow train arrives just before the green train. And then the purple train comes a little bit later, every 20 minutes. You're trying to figure out when will all 3 trains be at the train station at the same time. If you continue listing out the multiples, you should come up with 40 as the least common multiple. Now be careful, because you might see that 20 right here shows up in 2 of my lists, but it does not show up here. So I have to keep going, and 40 would be my answer. So 40 minutes. Now there's another way to find LCM, and that's using prime factorizations. So what I've done is I've found the prime factorizations of 21 and 30. So I used factor trees to do that. Once I have their prime factorizations, all I need to do is circle the number of factors that show up in each list. So for example, I'm going to look for 2's, and I want as many 2's as I can get. 21 does not have any 2's at all, so I'm going to look at the number 30. 30 has 1 2, so I'm going to take it and I'm going to write it down. 1 2. Then I'm going to look for as many 3's as I can get. Now, they both each have 1 3. So it doesn't matter which 3 I circle. I could circle this 3 or I could circle this 3, but I can't circle 3's from both lists. And then I'm going to look to see how many 5's I can get. Well, I can get 1 5, and that's right there. And then I'm going to take as many 7's as I can get. And I would keep going. So if there were more prime factors, I would keep doing this until I didn't have any more prime factors. Then I need to multiply to get my answer. And the answer is 210. So that means the LCM of 21 and 30 is 210. So this is actually a pretty fast way of doing this, considering if I were writing a list of all of the factors of 21, I would have to write 21 and then 42, and I'd have to keep going. And chances are you might not know your 21s very well, and so this would be hard for you. 30 wouldn't be too bad, but still, that's a long way to go up to 210. So this is meant to be a faster way of finding LCM. So let's try that. We'll find the LCM of 16 and 30. Go ahead and make a factor tree and press pause to find your answer. So my factor trees are done, and the prime factorization of 16 is 2 to the 4th power. And the prime factorization of 30 is 2 times 3 times 5. So I want to look between both of my lists which number has the most 2's. You're right, it's 16 has the most 2's, so I want all of them. So over to the side, I'm going to write 2 to the 4th. I want all of those 2's. Now I'm going to look and see, which number has the most 3's? 30 does. I'm going to take that 3. I'm also going to take that 5. Then I'm going to multiply. Before I multiply, I have to erase my mistake. This is not 15. This should just be 5. 3 times 5. So basically what I'm doing is I'm taking 16 times 15, and that should be 240. So the LCM of 16 and 30 is 240. Try this one on your own. Find the LCM of 24 and 36. Press pause and work out the problem, and when you're ready, press play to get the answer. So here's the prime factorization. I'm going to select all of these 2's, and I'm going to select all of these 3's. So I know that 2 to the third power is 8, and I know that 3 times 3 is 9. Therefore, my LCM is 72. Here is a story problem. You can choose which way you want to solve this problem. So you can read the story, press pause, work out the problem, and press play when you're ready for your answer. So in this problem, you're trying to find out in how many days will you have to take out the garbage during a full moon? Well, every 5 days you have to take out the garbage. Every 28 days there's a full moon. So you need to figure out the common multiple, the least common multiple of 5 and 28. So my prime factorization of 5 is just 5. And the prime factorization of 28 is 2 times 2, which is 4, times 7, which is 28. Okay, well, I'm going to take those 2's, I'm going to take this 5, and I'm going to take this 7. And if you'll notice, basically, I'm going to be doing 28 times 5. 28 times 5 is 140. So go back to see how you have to label this. In how many days? Well, it's going to be 140 days. That's my answer. Here's a problem for you to try, this time with 3 numbers. And you can press pause now, and when you're ready for the answer, you can press play to see how you did. So the prime factorizations are listed over here. What I did was choose the number that has the most 2's. That's 6, so I wrote down 2. Then I chose the number that has the most 3's, 2 3's. And then I chose the number that has the most 5's, 1 5. 5 times 2 is 10. 3 times 3 is 9. 10 times 9 is 90. Okay, last LCM problem to try on your own. This time, if you want to use prime factorizations, go for it. Or if you want to list them all out, you can do that too. Go ahead and press pause right now, and when you're ready for the answer, press play. So I have the prime factorization of 8 is 2 times 2 times 2. That's for 8. The prime factorization of 12 is 2 times 2 times 3. And the prime factorization of 15 is 3 times 5. Then I want to circle the number with the most 2's, circle the number with the most 3's, doesn't matter, because they both each have 1. Then I'm going to circle the number with the most 5's. Okay, so now I've got 2 to the third power times 3 times 5. 2 to the third power is 8. And 3 times 5 is 15. I'm going to make this even easier. I'm going to do 8 times 5 first because that's 40. And then I'm going to do 40 times 3, which is 120. So my answer is 120.